Hello, this is Tom. This is a presentation of machine learning project number 4, focused on logistic regression and Adeline. Got a couple things staged here. This guy does take a little bit to run, so I need a little bit more horsepower. So I'm running this in Google Cloud Platform on a compute engine, so just a VM with Ubuntu, and then Python 3, and then the NumPy and Pandas libraries. I bring this up just so you can monitor things. We've got the logistic set up here, and then we have the Adeline. So let's go ahead and get these running. And then our Adeline iterations. We'll let these go ahead and get started. We should see our stuff kind of spin up here, and then I'll pause the video and then come back to the end and then go ahead and explain everything. We see our gradients here start to be spit out. Have these iteratively being spit out, not on every particular, or rather every specific iteration. It's just periodically, like every 100 training rows. Alright, I'm going to go ahead and pause the video and come back after these things have completed. Okay, and we're back, and we see everything is completed here across both of the logistic and the Adeline. Here's the status update on the GCP. Again, this was just something I used because I need a little bit more horsepower. I went with 16 virtual CPUs and about 120 gig of RAM. So here's the results. Intermittently, we're putting out the gradient, and these are the samples per iteration. So we've got each row represents a class, and each column represents a feature. You can see the one hot encoding here. So this is for cancer data, the glass data, iris data, soybean data, and then our voting data. Switching over to here, we can see the same pattern where we've got gradients and then our sample weights per iteration across all of these, and our overall results at the end. So one other item just worth mentioning, and I will talk about a little bit more in the paper, is that you'll see the results are exactly the same. The algorithms are very, very similar. I may have missed a key point in the lecture, but essentially the only difference I've got in the implementation side is that I've got on the Adeline division by the number of observations per class when I'm doing the reweighting. So I talk about that a little bit in the paper. Anyway, this has been an overview of the functionality of the program, and please let me know if you have any questions.